Alright, so today we're going to be talking about completing the square. Completing the square is something that we will use whenever factoring is not easily done. Alright, so before we go into complete the square, I do want to talk about a few things. Okay, remember that when I have a number that is being squared, if I square root it to get rid of the square, I'm going to end up with two answers. So for example here, a plus or minus square root of 15. So just remember that this symbol is plus or minus and the square root of a. Alright, so let's go ahead and solve this equation. Now, we may subtract 59 and then look at this and say, is this a perfect square? Well, the answer is no. So it would not be easily factored. So what we can do though is we can see, since there's only one x term, x squared, we can actually subtract 11 from both sides, and I'll get 4x squared equals 48. That's a bad looking for. There we go. Now to continue solving for x, we would divide both sides by 4, and I get that x squared equals 12. Oops, sorry about that. So now what I do to solve for x is simply square root both sides. And when I do, I'm going to get x equals plus or minus the square root of 12. We can actually simplify the square root of 12. Remember how to simplify your radicals. So I would simplify the square root of 12 as 2 square roots of 3. So my answer here should be plus or minus 2 square roots of 3. Alright, now in a problem like this, what I notice is that I can actually factor this expression into x plus 6 times x plus 6. We could also write that as x plus 6 squared. So x plus 6 squared equals 28. In order to get the x plus 6 by itself, you would square root both sides. So I'm left with x plus 6 equals plus or minus the square root of 28. Now remember, we can break down the square root of 28 into plus or minus 2 square roots of 7. So x is still not by itself. I need to get rid of this plus 6 by subtracting 6 from both sides. So I get negative 6 plus or minus 2 square roots of 7. Alright, so here's our first you try. Go ahead and pause and give this problem a shot. Alright, so by adding 20 to both sides, dividing by 4, and square rooting, you should get that x is equal to plus or minus 5 halves. Alright, so as we continue, I'm going to introduce to you algebra tiles. Some of you may have already worked with algebra tiles, depending on your learning style in a previous lesson. So if we take a look at this first box here, this box is actually an x by x. Now x by x means x times x is x squared. The area of this big square is x squared. Now this rectangle has a length of x but a width of 1, so 1 times x is simply x. This little square has a width of 1 and a length of 1, so 1 times 1 is 1. So in the algebra tile language, what is x squared plus 2x plus 4? So we need 1x squared, we need 2 x's, and 4 1's. Oops, there we go. So that is what x squared plus 2x plus 4 will look like. Now what about 2x squared minus 4x plus 1? Before we do this problem, I want to talk about negatives. On the reverse of each one of these tiles is a red side, and the red means negative. So in the case of 2x squared, we have 2x squareds, but we have negative 4x's. So we have to make sure that our tiles appear on the red sides. And then plus 1. So what you see here is 2x squared minus 4x plus 1. So just remember that with algebra tiles, we can actually set up multiplying polynomials, okay? So we have, for example, x squared plus 2x plus 1, and we break it down into the factor x plus 1, x plus 1. So this is kind of that reverse method that we talked about in the previous videos for factoring when a was not 1. Now with completing the square, what we're going to be doing is we're going to make the square that you saw on the previous page. And in order to do that, we're going to have an x squared, an x term, and then we're going to have a blank. It is our job to fill in the constant. How many of those little yellow 1 tiles do we need to make this into a perfect square trinomial, meaning that I end up with like x plus 3 squared? And this is important because we're going to need to put this into vertex form, and you'll remember that vertex form has x minus a number squared. Okay, when we convert from standard to vertex, we need to complete this square and get this x minus h squared box. Now, in order to get the number, all you have to do is take the middle number b and divide it by 2 and square it. That will be how you get the number that belongs as your constant. So with the algebra tiles, we can take a look here. Okay, this is x squared plus 6x plus the blank, according to our previous example. So I put out the x squared tile, and I make my 6x to be 1, 2, 3, 4, 5, 6. Now I'm putting it in a square shape. I've divided the 6 evenly into 2. So I have 3 on one side of the x squared and 3 on the other. Now it's my job to fill in the remaining parts of the square, i.e. completing the square, by adding little 1 tiles. And you'll notice that I need to add 9 tiles, because 6 divided by 2 is 3, and 3 squared is 9. So let's try that here. We have a negative 14 as our b. So negative 14 over 2 and squared. So I get negative 7 squared is a 49. So 49 belongs in this box. If I were to factor this out, two numbers that multiply to 49 to add to negative 14 are negative 7 and negative 7, or as we would write it, x minus 7 squared. Occasionally we will get a problem that will result in a fraction. Okay, so what we have here is 9. 9 over 2 does not simplify very pretty. So we'll leave it as the fraction 9 halves, and when we square it, we get 81 over 4. So 81 over 4 is what belongs in this box. So when we actually factor this out, what we're going to do is it's going to be x plus 9 halves squared. And where I get this 9 halves from is inside the parentheses. All I did was take the middle term and divide it by 2, and that gives me what I need inside. Just remember that this sign right here, this plus, comes from the plus sign of the middle term. All right, why don't you try this example? So our middle term is 4, and we divide that by 2 and get 2. And then we square it and we get 4. So the constant that I need is 4, and when I multiply this, I get x plus 2 squared. All right, so we can use complete the square to solve harder equations that are unfactorable. Okay, let's start with one that's pretty easy. X squared minus 12x plus 20 equals 0. Your first job is to get rid of the constant and move it to the other side. So we get this. Now what I'm doing is I'm putting a plus blank on either side, because I know that in order to complete the square, a number needs to go here. But remember, you cannot add a number to one side without adding it to the other. So I look at my middle term, negative 12, divide that by 2, and I get negative 6, and square that, I get a plus 36. So in order to complete the square, I need to add 36 to both sides. Now this left side is factorable, x minus 6 squared, and negative 20 plus 36 is 16. Now all we need to do is square root both sides. X minus 6 equals plus or minus 4. Do you see that plus or minus? You cannot forget that. So by adding 6, to both sides, I get x equals 6 plus or minus 4. Now we can actually simplify this a step farther. Okay, here's what we need to do. 6 plus 4 is 10. 6 minus 4 is 2. So the two values that x can be are 10 and 2, which means my x-intercepts are at 10, 0 and 2, 0. So because I got nice even answers here, I know that I actually could have factored this in the beginning. But if you don't remember, or you can't say I can't seem to find a factor, we can use complete the square. Now in a problem like this, the first thing I would do is find the GCF and divide everything by that. So I see that 3 goes into 3, 18, and 45. So when I pull that out, and I'm going to go ahead and leave my plus blank, okay, here's what I have. Now I'm going to look for the number that belongs in this blank, so I divide 6 by 2 and square that, I get 9. What I add to one side, I add to both. So this becomes factorable x plus 3 squared equals, and 15 plus 9 is 24. So square root both sides. Whoops. Don't know where that came from. Sorry, guys. And the square root of 24 is really 2 square roots of 6. Subtract 3 from both sides. I get negative 3 equals plus or minus 2 square roots of 6. Now, we cannot simplify this. If you put in your calculator negative 3 plus 2 square roots of 6, it would spit back out the same answer. So this is the answer in its most simplified form. Alright, so why don't you go ahead and pause the video and try this problem here. Remember to look for your GCF first. So the GCF that I find is 3. So we have x minus 8, excuse me. 8x. Go ahead and put my plus blanks here. 27 divided by 3 is 9. So negative 8 divided by 2 is negative 4, and square that I get 16. So I get x minus 4 on this side equals 9 plus 16 is 25. Square root of both sides, x minus 4 equals plus or minus 5. Add 4, so I get 4 plus or minus 5, which means my two answers are 4 plus 5, 9, and 4 minus 5, negative 1. So my two x-intercepts here are 9, 0, and negative 1, 0. Alright, so taking what we learned, now we're going to begin changing from standard form to vertex form using the complete the square method. So here we're given an equation, f of x equals x squared plus 16x minus 12, and I want to write it in vertex form and identify the vertex. Okay, the first thing we're going to do is this f of x and this equation on the right is going to get a plus blank. And the reason for that is I want to factor this section to make it the parentheses x minus h squared that we need. So 16 over 2 squared will be 64. Okay, so let's go ahead and factor this part out since we have it this way, x plus 8 squared, and then minus 12. So we still have our f of x plus 64 over here. Now we got to solve for f of x, so subtract 64 from both sides. F of x will be equal to x minus 8 squared. Negative 12 minus 64 is negative 76. So what we have here is a vertex at 8, negative 76. Oops, that actually should be a plus 8 there, which would then change this to a minus 8. My bad, I don't know why I wrote that. Alright, let's go on to the next problem. Okay, 3x squared minus 18x plus 7. We're going to put a blank on both sides. Maybe. And then make sure that when you put the blank on the second side, it goes after the x term. So negative 18 divided by 2, and then I square that. Actually, here's what needs to happen. I see that 3 will actually go into 3 and 18. So by factoring out a 3, I now know that my a term will be a 3 out front. So negative 6 over 2 squared is 9. But here's the problem. We don't actually add 9 to the left side. We add 9 times 3, or 27, to the left-hand side. So factoring out this, we get x minus 3 squared. Subtract 27, we get negative 20. So the vertex is at positive 3, negative 20. Alright, so in this problem, it was similar to the previous problem. We had to pull out a 5 from the 5x squared and negative 50x. So we found 25 to be the c, so 125 to add vertex here would be 5, 3. All right, that's it for today. We'll do several examples, and I will see you later.